Hello everyone, in this video I will do final revision. It is the same as the final exam. The first part of the exam about the circular motion, then we go to the formula sheet and revise the rules of circular motion. So that are the rules of circular motion. Yeah. Yes, now just to get an idea about the rules or the formulae of motion in a circle. And then we go to extended question contains circular motion. First, we have to revise together the definition that you need to memorize. Radian. Radian is the angle subtended at the center of a circle by an arc equal in length to the radius of a circle. Angular speed, the angle swept out by the radius of the circle per unit time. Now we solve question number 1. We write the given here. Mass, so this is M, equals 50 gram. We convert it to kilogram, divide by 1000. So it will be 0.05 kilogram. Circular track of diameter. So this is the diameter equals 76 centimeter. We know that the radius is half diameter. So it's half diameter. We divide by 2. Then the answer is 38 centimeter. We convert to meter, divide by 100. So it will be 0.38 meters. So this is the radius. Completing one revolution in 12 seconds. This is the time period, the time of one revolution, 12 seconds. Calculate the linear speed. The formula for linear speed, it is not in the formula sheet. The linear speed denoted by V equals the distance over time. The distance is the circumference because one revolution, so it's 2 by R, divided by the time of one revolution is the time period. Substitute 2 by multiply the radius in meter 0.38 divided by the time period 12. The answer is 0.2 unit is meter per second. Second part, the angular speed. Now we go to the formula sheet. Okay. Yes, the angular speed V equals omega R. So this is the angular speed. V equals omega R. So we can get omega from this. Now return back. Here. We write this formula here. So this one. V equals omega multiply R. We need omega. Omega equals V over R. V is the linear speed. R is the radius. The linear speed is 0.2. The radius is 0.38. The answer is 0.5. The unit of angular speed is radian per second. Part C, the centripetal acceleration. Now, the centripetal acceleration, where is the acceleration here? It is V squared over R. So this is the centripetal acceleration. Then, right here, the acceleration equals omega squared R, or because already we got omega, then we can use omega better than V, or V, both will be correct. But because already omega in the calculator, we use it, so it's omega. Omega is 0.5 squared multiply R 0.38. The answer is 0.10. The unit of acceleration is meter per second squared. Next part, centripetal force. The force equals MA. M is the mass. Already the mass is given it is 50 gram, 0.05 kilogram, and the acceleration already we calculated before. Then it is 0.05, this is the mass, multiply the acceleration 0.10, the answer is 5.26 multiplied by 10 to the power negative 3 Newton. Next question. Satellite orbit the Earth 200 kilometers above. Then we draw the circle. So we draw the Earth here, and the circle. Now. So this is the center of the Earth, and this is the radius of the Earth, denoted by R capital, and this is the height of satellite, denoted by H. So this is the satellite here. This is the satellite. The height, satellite orbit the Earth 200 kilometers above. Then H is 200 kilometers. We have to convert to 2 meters. The acceleration towards the center. So this is the centripetal acceleration. A equals 9.2 meter per second square. The radius of the Earth, denoted by R capital. So R capital equals 6,400 kilometers. Calculate the speed. We need to calculate R small. What is the relation between R small, R capital, and H is that? Remember, R equals R capital, the radius of the Earth, plus the height. So the first step, we calculate R. Then R small equals R capital plus H. R capital 6,400 plus H 200. So it becomes 6,600 kilometer. We convert to meters, then R equals 6.6 multiply 10 to the power 6 meter. So this is the R. The speed of satellite, we have acceleration. The relation between linear speed acceleration is that A equals V squared over R. Then V squared equals A multiply R. We calculate V squared and then we take square root of the answer. So V squared equals A is given 9.2 multiply R 6.6 times 10 power 6. So V squared equals 6.07 multiply 10 power 7. Take a square root of the answer. So V equals 7.79 multiply 10 to the power 3. The unit is meter per second squared. The time to complete one orbit, the time revolution. So we need T capital. We know that in the triangle here, V equals omega R. Then we can get omega. So omega equals V over R. What is omega and the relation between omega and time period? Omega, it's 2 pi over T, the time period. First, we calculate omega. So omega equals V 7.79 multiply 10 power 3 divided by R. R, it is 6.6 times 10 power 6. The answer of omega is 1.18 times 10 to the power negative 3 radian per second. Now, omega is 2 pi over T. So 2 pi over T equals 1.18 multiply 10 power negative 3. Rearrange this formula to get T. So T equals 2 pi divided by 1.18 times 10 power negative 3 by using calculator. The answer is 5.32 multiply 10 to the power 3. The unit of time period is second. Next question. Now this is the multiple choice. So we solve it extended and then we go to multiple choice. The diagram shows a disk of diameter. Then here we have the diameter equals 120 millimeter. We find the radius, half diameter, 60 millimeter. Convert to 2 meter divided by 1000, so it is 0.06 meter. That can turn about an axis through its center. So it is circular motion. The disk is turned through angle of 30 degrees. So this angle in degrees, but we have to convert it to radian. How can we convert the angle from degree to radian? Remember, pi in radian equals 180 degrees. Then we put here 30, and then we do cross multiplication. So the angle in radian is 30 pi over 180. This is theta in radian. By using calculator to simplify, it will be pi over 6. Then our angle 30 degrees in radian is pi over 6. In 20 milliseconds, so this is here, the disk turned through an angle, so this is t small, this is not the time period, just t small. So t small, 20 milliseconds, we convert to 2 seconds, 20 multiplied by 10 to the power negative 3 to be in seconds. This is t small, not the time period. What is the average speed? The average speed or the speed here, V equals omega r. So we need omega. First of all, we calculate omega. How can we calculate omega? From the formula sheet, omega equals theta over t. But theta must be in radian and t in second. Angle theta in radian is pi over 6. Over the time period, not time period, 20 multiply 10 power negative 3. The answer is 26.18 radian per second. We need the speed. So the speed V equals omega r. Omega is 26.18 multiply r 0.06. The answer is half pi meter per second. Then the correct answer is half pi meter per second. Now, next part about gravitational field. We go to the formula sheet here. So gravitational field, F equals G m1 m2 over r squared. V is the speed of satellite, G m capital over r under square root. G, gravitational field strength, F over m, and so on. And remember, the constant here is given, G equals, so this is the given for G, and also this is the radius of the earth, r capital, and this is the mass of the earth, and this is G on the surface of the earth. Now we go back to the extended question. Before, we have to revise the definitions. Newton's law of gravitation states that two-point masses attract each other with a force that is proportional to the product of their masses and inversely proportional to the square of their separation. Gravitational field strength at a point is the force per unit mass acting on a small mass placed at that point. Gravitational potential at a point is gravitational field in a gravitational field is the work done per unit mass in bringing a small test mass from infinity to the point. You can abbreviate this definition. For example, Newton's law of gravitation, we can say the force proportional to the product of masses and inversely to the square of separation. Gravitational field strength is the force per unit mass. Gravitational potential at a point is the work done per unit mass in bringing the test mass from infinity to the point. Now, just remember the keywords of each definition. Now, question number 4. Masses of Sun and Earth are, so this is M1 in kilogram, and this is M2 in kilogram. The separation is in kilometer. Oh, this is R. Then we have to convert to meter. 1.5 times the 10 power 8 kilometer. To convert to meter, multiply by 10 to the power 3. Then the answer is 1.5 times 10 to the power 11 meter. This is R. Calculate the force of attraction. We need F. The formula from the formula sheet is that F equals G M1 M2 over R squared. G, it is a constant. It is given in the formula sheet. G equals 6.67 multiplied by 10 to the power negative 11 multiplied by M1 2 times 10 power 30 multiply M2 6 times 10 power 24 divided by R squared in bracket 1.5 times 10 power 11 all squared. The answer is 3.56 multiplied by 10 to the power 22 Newton. Now, next, for geostationary satellite, it means that the time period of satellite, it is the same as the time period of the Earth. It's 24 hours. So first of all, from the word geostationary, T equals 24 hours. So 24 multiply 60 from hour to minute, multiply by 60 to second. Then the answer in second is 8.64 multiply 10 to the power 4 second. He said drive. The speed of satellite is V equals. Now, we need to drive this. Follow me. First, we draw here. This is the Earth here. And this is the satellite. Okay, now. This is the distance from satellite to the Earth, denoted by R. So this is R. Now, the Earth's mass denoted by M capital and satellite denoted by M small. We have attraction force, gravitational force between M small and M capital from Newton's law. Fg equals G M over R squared. But this gravitational force provided the centripetal force. The centripetal force is M, depends on the mass of satellite, mv squared over r. They are the same. So Fg, the gravitational force, is the centripetal force. Then G, M capital, M small, over r squared equals m v squared over r. Simplify. How to simplify? First, we cancel m small with m small. Multiply by r both sides to cancel this. Then r squared from this formula equals gm. We cancel one r with r over r. So this is v squared. So v squared here. V squared equals gm over r. Take a square root of both sides, then v, the speed of satellite, is a square root of gm over r. Remember, the speed of satellite does not depend on the mass of satellite. It depends on the mass of the Earth. M capital is the mass of the Earth. R is the distance from satellite to the center of the Earth. We ignore the radius of satellite because it's very small compared to the distance from satellite to the center of the Earth. Now, we need the height above the Earth. Now, just we have here the time period. So the time period we calculated it before. The time period it was 8 0.64 multiply 10 to the power 4 second. We need the height, so we need h. Now, the height here is what here? So this is the radius of the earth here. Okay, we need the height, okay, above the earth's surface. So we need r. No, we need here h. So we need h. H is the height from satellite to the surface of the earth, and r is the radius of the earth. The radius of the earth is given in the formula sheet here, the gravity, the radius of the earth. So it is given in the formula sheet. It's constant. Now, also it's given in the question. The radius of the earth is 6 points. This is r capital, and this is the mass of the earth m capital. Now, to get h, we need r small, because we know that r equals h plus r. So h equals r small minus r capital. What is r small? It is the distance from the center to satellite. R capital is the radius of the earth, which is given. Now we need to calculate r small. What is the formula? We know that v, the speed of satellite, it's 2 by r over the time period. Circumference over time. And we know that v equals square root of g m over r. So equate them together. Then 2 by r over t capital, time period, equals square root of gm over r. Squaring both sides, then 2 squared is 4 by squared r squared over what? Over t squared equals g m over r. What I did, I squared both sides. So squaring both sides, this is square and this is square. Okay. Now multiply by r, because we need r in one side as a subject. So multiply by r, multiply by r. Then here r times r squared is r cubed. Then we have here 4 by squared over t squared r cubed. You cancel r with r equals gm. Now substitute. So 4 by squared in calculator, t time period, I said it's 8.64, then in bracket 8.64 multiply 10 power 4 all squared, this is the time period, multiply r cubed equals g is constant, 6.67 multiply 10 power negative 11 multiply the mass of the earth. The mass of the earth is constant, given in the question and also will be given in the formula sheet, 5.98 times the 10 power 24. So multiply by 5.98 multiply 10 power 24. From this you can take cubic root of the result, then you will get r. So r equals 4.23 multiply 10 power 7 meter. From r we can calculate h, the height. So r small minus r capital. R small is 4.23 times the 10 power 7 minus r capital. R capital is the radius of the earth, 6.3. Take care for the unit, the same unit, meter and meter. Then the answer is 3.59 multiplied by 10 to the power 7 meter. Part C, we need the speed in orbit. So the speed in orbit, we can say V equals 2 by r over t, no problem, or square root of gm over r, the same. Okay, now it's 2 by r, which r small. R small is 4.23 times the 10 power 7 divided by the time period 8.64 multiply 10 to the power 4. By using the calculator, the answer is 3.07 multiply 10 to the power 3. The unit is meter per second. Next question. Planet's mass is, so we have m. Radius of planet is. The spacecraft in orbit planet at height above the surface. So that the speed. Now, what are the givens here? We have m capital, 7.5 times the 10 power 23 kilogram. And we have the radius r capital, 3.4 multiply 10 to the power 6 meter. The spacecraft to orbit planet at height, we have h equals 2.4 times 10 power 5 meter. From r and h, we can calculate r small. R small equals r capital plus h, the radius of planet plus the height. Then r equals 3.4 multiply 10 power 6 plus 2.4 times 10 power 5. Then the r small is 3.64 multiply 10 to the power 6 meter. We said above that, show that the speed of satellite. Now we need to get V. What is the formula that we can use? We can go to the formula sheet. We can find this. V equals Gm over R. Now you can use either V equals 2 by R over time period or Gm over R. Both are correct and you will get the same answer. Then the answer is square root of G equals 6.67 times the 10 power negative 11 multiply m is the mass of planet, 7.5 times the 10 power 23 divided by r small that we calculated, which is 3.64 multiply 10 to the power 6. By using the calculator, you will get the same answer. 3.71 multiply 10 power 3 meter per second. Next question. The radius of the Earth and gravitational field strength drive the gravitational field strength G. Now, how can we drive this? We know that the gravitational field strength is the force per unit mass. Now, here, if we have here the Earth, this is the Earth, this is the Earth here. Okay, and okay, I said this is the object of mass m. Then we have here the mass of the Earth denoted by m capital and the object denoted by m small. And because it is on the surface, so the distance is r capital. R capital now is r small because there is no height, he said, on the surface. Now we need to drive the gravitational field. We said G equals F over M, but F is the gravitational force. It is G M capital M small over R squared. Substitute from equation 2 in equation 1. Then G equals G M capital M small over R squared divided by M. Cancel M small with M small, then you will get G M over R squared. This is the derivative. Assuming that the field is radial, calculate the mass of the Earth. Now, he gave us G on the Earth 9.81 Newton per kilogram. So this is the given. We need to calculate the mass of the Earth. We use the formula G equals Gm over R squared. Rearrange it to get M. Then M equals G R squared over G capital. Then we can calculate the mass of the Earth from this formula. G is 9.81 on the surface. Multiply R capital equals R small equals the radius of the Earth. So this R small equals 6.38 multiply 10 power 6 meter. Then divided by, so multiply, open bracket, 6.38 multiply 10 to the power 6 all squared divided by G capital 6.67 multiply by 10 to the power negative 11. The answer is 5.99 multiply 10 to the power 24 kilogram. Now, next part, he said the radius of the moon's orbit about the Earth is calculate the strength of Earth's gravitational field at this distance. Now, what do we have here? We have two objects. So here we have two objects. Sorry. Yeah. Now we have here two objects. First, this is the Earth, and this is the moon. Okay. Okay. This is the height from the Earth to the center. He said orbit about, okay, the radius of orbit. So this is r small. So r small is 3.84 multiplied 10 power 8 meter. This is m small and this is m capital. What do we need? We need to calculate the strength of the Earth's gravitational field at this distance. So we need to calculate G at this distance, okay, related to the mass of the Earth, not the mass of the moon. This is not G related to the mass of the moon. No, G because the gravitational field is strength of the Earth. Then G equals G, M is the mass of the Earth, not the moon, over R squared. Then we do substitution. 6.67 multiply 10 to the power negative 11 multiply the mass of the moon that already we calculated 5.99 5.99 multiply 10 to the power 24 divided by r, it is the radius of the orbit, 3.84 multiply 10 to the power 8 all squared. By using calculator, it's 2.71 multiply 10 to the power negative 3 Newton per kilogram. Next question. The Earth has mass, so this is m of the Earth, and radius, this is r capital, so this is m and this is r. Now, if you don't know the meaning, no problem, this is an object. Measured of mass, this is m small. Moves from infinity, so from infinity, moves from infinity to the Earth. So this is the Earth, it moves from infinity to the Earth. The magnet starts from rest, so the initial speed equals 0. Explain why the acceleration of free fall near to the Earth's surface is approximately constant. Why? Because near to the surface, the lines are parallel. So constant field strength, hence constant acceleration of free fall. We write this one near to the surface, the lines of force are parallel. So constant field strength. Hence constant acceleration of free fall. Hence constant acceleration of free fall. This is the answer of part A. Now, the change in gravitational potential. Now we go to the formula sheet. Gravitational potential here is that one, Gmm over R. So this is the EB or gravitational potential. We return back. Now, the change in gravitational potential denoted by delta EB, gravitational potential, equals the negative G M capital M small over R. We do substitution. We have M capital, we have M small, and we have also now what is here R here? He said, okay, the gravity of the Earth. Now we need to change it until to the surface of the Earth. Then R small is R capital here. Then we use this formula, negative 6.67 times 10 to the power negative 11. M capital, the mass of the Earth, 6 multiply 10 power 24. M small is 220 until the surface of the Earth. So R capital equals R small. So it is 6.4 multiply 10 to the power 6. By using the calculator, the answer is negative 1.4 multiply 10 power 20 joule. This gravitational potential energy in joule. The speed which it strikes, strikes the Earth. Now, this is the change in gravitational potential energy. What is the relation between gravitational potential energy and the speed? It is kinetic energy. It's half m v squared. Then what is m? It is the mass of the moderate. It's 220. Then from this formula, we can say half m v squared without the negative. Okay, we take the absolute value, 1.4 times the 10 power 20. M is the mass, small mass, multiplied by 220, multiply v squared equals 1.4 times the 10 power 20. From this, you can get v squared, 1.25, times the 10 to the power 8. Then v equals square root of the answer. It's 1.12 multiplied by 10 to the power 4 meter per second. Remember, any speed must be less than the speed of light. The speed of light, denoted by c, it is 3 times the 10 power 8 meter per second. So any speed must be less than the speed of light in any calculations. Next question. Okay, in this question here, spherical planet, so the name is not important for us, may be assumed to be isolated in a space. The variation with distance x, so this is the distance x here, from the center, and the gravitational potential phi. So this is the gravitational potential, okay, x and phi. Now, the gravitational potential phi at distance r from the point mass m is given by the expression, okay, where g is the gravitational. Explain the significance of the negative sign. Negative sign because the gravitational potential at infinity is zero. The gravitational force is always attractive, and so the test mass moves from infinity, so it is decreases. Now, the answer of this one, why is this negative? Be right. Gravitational potential at infinity is zero. Gravitational, okay, potential at infinity is zero. Is zero. Gravitational force is always attraction. Gravitational force is attraction or attractive force. And so the test maps, so the test mass moves from infinity, moves from infinity. It means decreases from zero. So decreases, so it's negative, decreases. So it is negative because less than zero. At infinity is zero. When we go to direct it toward the Earth or planet, so it will be less than zero. It means it's negative. Next question. The radius is 480 kilometers. So this is R. Determine the value of phi on the surface. On the surface now. Here, what is the relation between r? This is the distance here. This is x. We said this is a variation with distance x from the center. Now, what is phi on the center? Now, we calculate here the radius. Now, the radius is 48, we say r capital, it's better, 4800 kilometer. We convert to meter, okay? So this is 488, convert to meter, it's 4.8 times 10 to the power 6 meter. We can rewrite it as 0.48 times 10 power 7 meter. Why I write this? Because it's already here, it is 10 to the power 7. Now, at this point, this is 0.5. Multiply 10 power 7. Then 0.48, it is the point before that one. So this one here is this point is 0.48 multiply 10 to the power 7. Now we draw the vertical line and we go down. Okay. Until the curve. Of course, we use the ruler, not hand, in the exam. Until, yes, here, yeah, until this one. Then we find this one here. This point is negative 3.55 multiply 10 to the power 7. Then phi at the surface here, then phi from the graph is negative 3.55 multiply 10 to the power 7. The unit is joule per kilogram. Show that the mass equals. What is the relation between phi and the mass? From the formula sheet, phi equals the negative Gm over r. Rearrange this formula. So m, without the negative, we need to get the mass. It's r multiply phi divided by g. Already we got phi from the graph, then m equals 0.48, this is r, 0.48 times 10 power 7 multiply phi 3.55 without the negative because we calculate the mass, divided by g 6.67 multiply 10 to the power negative 11. The answer is 2.55 multiply 10 to the power 24 kilogram. Next part, calculate the gravitational field strength. Gravitational field strength G from the formula sheet, G equals G m over r squared. So we calculate this one equals G 6.67 times the 10 power negative 11 multiply m. Already we calculate m now. It's 2.55 times the 10 power 24 divided by r. R is 0.48 multiply 10 to the power 7 all square. By using the calculator, the answer is 7.4 Newton per kilogram or meter per second square. Now, next question. How much work is done by gravitational field in moving a mass of mass m 2 kilogram from infinity to a point which is distance 4 from the mass m? Now we have the scenario of this question. I draw it for you. Yeah. Okay. Now here we have the mass m. So this is a big mass. And then this is then the small mass. Okay. Now let us go back here. Now, what are the givens? How much work is done by gravitational field in moving a mass m? So this is the mass m, which is 2 kilogram. From infinity, at infinity, the gravitational okay, is negative 0. Now, we need here the work done, it is m times phi, from infinity to the point which is distance 0.4 from the mass. So this is here the distance r equals 0.4 meter, and the mass, the capital mass, is 30 kilogram. Now, the work done by the force, so the work done by the force, by external force, denoted by W, equals m multiply phi, which is negative m g m capital over r, or g m capital M small over r. We calculate this one. Then the answer is negative 2 multiply 6.67 times 10 power negative 11 multiply m capital 30 divided by r 0.4. So the answer is negative 1.0 times 10 power negative 8 joule. This is the work done by external force. So the work done by the field is positive. So the work done by the field is 1.0 times 10 power negative 8 joule. The same as the exam, we go to the multiple choice. It said the acceleration of free fall at the surface of the earth. So this is g at the surface. So the given g equals gm over r squared equals 9.81. The mass of the earth is m and the diameter is d. Now r equals half d. Then substitute. Then we can write gm over half d all squared equals 9.81. From this relation, we can say, simplify. So 4 gm over d squared equals 9.81. He said, which of the following gives acceleration at a surface of planet with diameter d over 2? Now, the relation is g proportional inversely to r. But now here the mass is m over 9. Then the new g new here is g, replace m by m over 9 and replace d by d over 2. So it's here half, replace d by d over 2, all squared. Simplify, you will get this one 4 over 9 multiply 4 gm over d squared. It means 4 over 9 multiply 9.81. Then the answer is B. Next question. Which of the following is not similar between gravitational fields and electric fields? Both fields act on, okay, this is similar on all particles. Yes, this is the similar. Now, next question. Here. Select the graph that shows correct the relationship between F and two masses and separation. We know that F proportional to R squared. F proportional inversely to R squared. Then if we draw the relation between F and R squared, we get this. But F proportional directly to 1 over R. Then the relation between F and 1 over R is direct. R squared is direct relation. Okay, then the correct answer here is D. So this is the relation between F and 1 over R squared, not R. Now we go to the third part, oscillations. We take a break, like exam, we take a break about 2 minutes and then we go to the formula sheet for oscillation. Just remember, A equals negative omega squared x, V equal positive or negative omega radical x naught amplitude squared minus x squared. And remember the equation x equals x naught sine omega t and V. So everything will be in the formula sheet. Now we return back to the extended question. Before to start the extended question, we have to revise the definitions. Now, Simple harmonic motion is the motion of a particle about a fixed point such that its acceleration, so that are the keywords. Acceleration is proportional to the displacement from a fixed point and in opposite direction. So that are the keywords you have to remember. Damped oscillations means the oscillating system experiences a damping force, causing its energy to decrease gradually. Resonance occurs when the natural frequency of vibration of an object is equal to the driving frequency, giving a maximum amplitude of vibration. Just write the keywords in the exam. Now, next, okay, here said describe examples of free oscillations. Now, the examples that are pendulum. This is example of free oscillation. Pendulum, mass spring, mass spring system, tuning fork, in all of that, restoring the force is directly proportional to the displacement and in opposite direction. Now, that are examples of free oscillation. Now, question number 15. Displacement x at time t of particle moving in a simple harmonic motion. So this is the equation where x is meter. Use the equation to find the amplitude, frequency, and period of motion. Just to compare this equation to the equation, x equals x naught sine omega t. By comparison, we can get direct x naught. So the amplitude x naught equals 0.36 meter and angular frequency omega equals 10.7 radian per second. From this we can get the frequency. So 2 by f, this is omega, remember it's 2 by f, and also omega equals 2 by over t. So 2 by f equals 10.7 divided by 2 by, you will get the frequency. It's 1.7, remember it's hertz. Now we need to calculate the time period, the relation between time period and the frequency. T equals 1 over f. So the time period equals 1 over the frequency, 1 over 1.7 equals 0.59 seconds. Find the displacement when t equals. This is the equation of displacement. Just replace t by this number, but remember the angle must be in radian. Then the displacement x at t equals 0.35, just so we do substitution. 0.36, this is the amplitude, sine, open bracket, 10.7 multiply t small, 0.35, but remember this angle must be in radian. So you have to convert your calculator to radian. The answer is negative 0.21 meter. Next question. From the acceleration time graph, this is acceleration time graph. What we deduce? We deduce the maximum acceleration. We don't deduce the amplitude. He said, determine the period, the frequency, the angular frequency. Okay. First of all, the time period, the time of one complete oscillation from crest to crest, it's 2 seconds here. Then the time period equals 2 seconds. What is the relation between frequency and time period? It's 1 over time period, so it's half hertz. Angular frequency, omega, equals 2 pi over time period. So it's 2 pi over 2, which is pi radian per second. Now, the maximum acceleration, it's direct from the graph. A naught, the maximum acceleration, equals 10 meter per second square. 10 meter per second. The amplitude. Now we can get the amplitude from maximum. But we have to go to the formula sheet to check here the oscillations. Here, the, okay, A naught, it is not mentioned here, so you have to remember the relation between maximum acceleration and amplitude. The formula that you have to remember, A naught equals omega squared x naught. Then this one equals 10. Already we have omega, so pi squared x naught equals 10. From this we can get x naught, it's 10 over pi squared. So the answer is 1.01, the unit is meter. Next question. Write an equation of acceleration time graph. Oh, what is the equation of acceleration? A equals A naught, no, negative A naught sine omega t. This is not the answer. We have to substitute. Then the equation, the required equation, A equals negative A naught, it's already given from the graph, sine omega, we calculated it, it's pi, multiply by t. So this is the equation, write the equation, and then find the acceleration when t. Now we replace t by this value. So A, when t equals 4.5, equals negative 10 sine by multiply 4.5 in radian. The answer will be negative 10 meter per second squared. Next question. Go down. Okay, now read the question. A particle of mass, then we have here m equals 95 gram, we convert it to kilogram, divided by 1000, so it is 0.095 kilogram. Oscillates in simple harmonic motion with angular frequency omega, it's 12.5 radian per second, and the amplitude, this is x naught, equals 16 millimeter, we convert to meter, so it is 16 multiply 10 power negative 3 meters, so this is x naught. So calculate the total energy. From the formula sheet, E total equals half m omega squared x naught squared. Now just we do substitution. So it's half multiply m is 0.095 multiply omega, it's 12.5 squared multiply x naught 16 times 10 power negative 3 squared. The answer by using calculator is 1.90 times 10 to the power negative 3 joule. Next part, the kinetic energy and the potential energy at half amplitude. Now, the kinetic energy here, E kinetic, the formula is that half m omega squared x naught squared minus x squared. Now, we need the kinetic energy at half amplitude. Then x equals half x naught. So x equals half multiply 16 times the 10 power negative 3. Then it will be 8 times the 10 power negative 3 meters. This is x. We need the kinetic energy and the potential energy at this displacement. Substitute half multiply m is 0.095 multiply omega, it's 12.5 squared, multiply x naught 16 times the 10 power negative 3 squared minus x 8 times the 10 power negative 3 all squared. By using the substitution, the answer will be 1.43 multiply 10 to the power negative 3 joule. We need here the potential energy. This is the total energy. What is the relation between the total energy and kinetic energy and the potential energy? We know that E total equals E kinetic plus E potential. Already we have E total, this E total 1.9. So E total 1.90 times the 10 power negative 3. Kinetic energy 1.43 times the 10 power negative 3 plus potential energy. From this, you can rearrange the formula to get the potential energy. Then Just we move this down here. So the potential energy, when you rearrange, move this to the other side, it will be negative. So the potential energy equals 0.47 multiply 10 power negative 3 joule. Next question. Read the question, be careful. A small metal ball of mass. So this is M equals 0.5 kilogram fixed by means of string. Okay, here. The ball is pulled small distance to one side and then released. The variation with time to the of the horizontal displacement. This is the displacement time graph. This is displacement and this is time. We can get the time period from this. It is the distance from crest to crest. So this is the time period. So the time period is 0.6 and the unit is second. And also we can get the amplitude. The amplitude from the graph, it is 4 centimeter. We convert it to meter, 0.04 meters. This is from what? From the graph. He said, use the motion of the ball. The motion of the ball is a simple harmonic. Use the data to determine the horizontal acceleration of the ball for the displacement x equals 2 centimeter. Now, we need the acceleration. So the acceleration, the formula for acceleration here, acceleration equals negative omega squared x. This is the acceleration from the formula sheet. And this is x. So x here, it's 2 centimeter. We convert to meter, 0.02 meter. Now we need omega. Omega comes from the time period. Already we have the time period from the graph. The time period is 0.6 seconds. Then we can get omega. Omega equals 2 pi over t. Then omega equals 2 pi over the time period over 0.6. The answer here is 10 over 3 pi radian per second. Now we need to calculate the acceleration at this displacement. So the acceleration equals negative omega squared x equals negative open bracket. Omega is 10 over 3 pi all squared multiply x 0.02 meter. The answer it will be negative 2.19 meter per second squared. This is the acceleration. Next question. It said the total energy E total. Sketch the graph to show the variation resistance of the potential energy. Now we need to calculate E total. What is the total energy? So E total equals half m omega squared x naught squared. Calculate the total energy. So the total energy equals half. M is the mass which is given 0.5 multiply omega, it's 10 pi over 3 squared multiply x naught, the amplitude, it's 4 multiply 10 power negative 2 squared. The answer of this one is 4.39 multiply 10 power negative 2. Now we need to draw the potential energy. Potential energy is open upward. Now it is a sketch. Then yeah, we draw a horizontal line. So this is a horizontal line here. Okay. Now just move this down. Of course, in the exam, you have to use the pencil in drawing and also use the pencil in multiple choice. Remember that, please. Just I move it up. And then we draw the vertical axis here. Can you see I don't extend the vertical axis to 0 down because it's energy. The energy is scalar quantity, must be positive. but the displacement may be positive or negative. So this is the displacement, and the vertical is the energy. Okay, yeah. So this is the energy. Now, the total energy is that one, 4.39. We can say this is 4.39 multiply 10. This is the maximum um, energy, or the total energy, 4.39 multiply 10 power negative 2 joule. And the displacement here is 4 centimeter from the graph. We return back to the graph. It is here 4 centimeter. Then here the displacement is 4 multiply 10 power negative 2. This is the displacement in meter. The same distance, 1, 2, 3, 4. 1, 2, 3, 4. Here the same distance. We calculate 1, 2, 3, 4, 5. Yeah, 1, 2, 3, 4, 5. So this is the negative 4 times the 10 power negative 2. Then we draw the border. Here, this is the border. And here also, this is the border. Now we need to draw the graph here. We return back until the maximum energy or the total energy. Then we draw the graph. So the graph looks like this. It is open upwards here. This is the graph of what? Of potential energy. So this is E potential, and this is 0, of course. Okay, so this is the sketch of what here? Of displacement potential energy. So this is the potential energy with displacement. Next question. A block of metal is fixed at one end of vertical spring. Here, this one, the amplitude of the oscillations, the variation is shown in the figure here. Now, describe particle examples of damping oscillations. Car suspension, this is damping, example of damping, car suspension. Okay, sorry. So car suspension. Also hydraulic door closer. Door closer that we use in the school, if you remember. It will be closes the door. Now, describe particle examples of resonance. Pushing a swing, this is example of resonance. Pushing a swing at its natural frequency. Musical instrument, guitar for example, musical instrument. Also bridge and building, bridges and buildings vibrate in natural frequency, buildings. So that are examples of resonance. Name effect shown in the figure. This effect is what here is the resonance. Here, this is the resonance maximum frequency. Okay, so this is okay. Here, this is resonance. Okay, when the external frequency matches the natural frequency, it will be vibrate with maximum amplitude. Then this effect is resonance. So the graph tells us about resonance. State and explain whether the block is undergoing a damping oscillation. Peak is not sharp, so it is damping. So we write here because peak is not sharp, so dampened. Okay, now next question. Now we go to the multiple choice here. Which of the following statement is true when the object performs simple harmonic motion about here? The correct answer here is the graph of acceleration against displacement is a straight line, yeah, of negative slope. So this is the correct answer. Now, next question. Number 21 here. A body moves with simple harmonic motion of amplitude. So this is x naught. And time period. So from time period here we can get omega. Omega equals 2 pi over 4 pi. So it means a half. What is the speed? We need v. When the displacement x equals 0.3 meter. Which formula we use it? This formula. V equals, of course, positive or negative, but here we take just one value, positive, square root of x naught squared minus x squared. By using substitution, the answer would be 0.2. So the answer is 0.2 meter per second squared. Now, pendulum of mass. Remember here, we have two important positions. This is the maximum position and this is the center. At the maximum position, the displacement is maximum, but also the acceleration is maximum because it's proportional to displacement, but the velocity is zero. At the center, the velocity is maximum, but the acceleration equals zero and the displacement equals zero. Then the correct answer of this one is here. We finish this, then we take break, and then we go to the next topic. I advise you in the exam, take break about 5 minutes between each part and the next. Now, we go to the formula sheet. This is the electric field. In electric field, we have to know the permittivity of free space, E naught, and also this is the electron charge and electron mass. So now we go back to the extended question. Before to go to the extended question, we have to revise the definitions: Coulomb's law, electric field strength at a point, electric potential at a point, potential difference. That are the very important definitions. Also, electric field strength. So remember that definition is in front of you. Yes. Now, okay, now question number 23. He said, gravitational fields and electric fields show a certain similarities and certain differences between gravitational and electric. State one aspect of gravitational and electric field where they are similar. Force in both is proportional inversely to r squared. So the force in both is proportional to inversely to r squared. Difference: gravitational force is always attractive, but electric force may be attractive or repulsive. So gravitational force is always attractive, but electric force depends on the type of charges, is attractive or repulsive. Next question. Calculate the force on alpha particle of a charge. So this is Q1 that is situated in vacuum distance. This is R of a gold nucleus. This is Q2. Now the formula from the formula sheet, F equals what? Q1 Q2 over 4 by epsilon naught R squared. Epsilon naught is constant. It's given in the formula sheet. So here we do substitution. So Q1 3.2 times the 10 power negative 19. Q2 1.3 without the positive or negative. We take absolute value. 10 power negative 17 divided by 4 by epsilon naught 8.85 times 10 to the power negative 12 multiply R 3.2 times 10 power negative 7 all square. By using calculator, the answer is 3.65 multiply 10 to the power negative 13 Newton. Next question. Next question. Two equal point charges are 3 centimeter apart. This is R. We have to convert. So it is 0.03 meter. Repel each other with a force. We have here the force. It is in Newton. Sorry. Force equals 4 times the 10 power negative 5 Newton. But we don't have the charge. What is the value of each charge? So we say let Q1 equals Q2 equals Q. Then we use the formula F equals Q1 Q2 over 4 pi epsilon naught R squared. Substitute. So 4 multiply 10 power negative 5. Q equals Q1 Q, Q2 equals Q2, Q times Q is Q squared over 4 pi epsilon naught 8.85 times 10 power negative 12 multiply R, the distance here, it is 0.03 squared. From this, we can get Q squared, it's 4 times the 10 power negative 18. And from Q squared, we take square root, so it's 2 times the 10 power negative 19 coulomb. Next question. Calculate the acceleration. Oh, acceleration is A. On electron. Oh, we have here, when we go to the formula sheet, so for the electron, this is the mass of electron here. This is M for electron. And this is the charge of electron, Q, electron charge. Then, okay, electron in uniform electric field strength. So we have here E. Which formula we use it? F equals EQ. Why we find the F? Because we can get acceleration from the force. So F equals EQ. E is the electric field strength. It's given 5 times the 10 power 2. Q is the charge of electron 1.6 times the 10 power negative 19 coulomb without the negative. 1.6 times the 10 power negative 19. The answer is 8 multiply 10 to the power negative 17 Newton. What is the relation between the force and the acceleration? F equals ma. M is the mass of electron. It's given in the formula sheet, 9.11 times the 10 power negative 31 kilogram equals 8 times the 10 power negative 17. Then the acceleration equals the force 8 times the 10 power negative 17 divided by the mass of electron is 9.11 times the 10 power negative 31 kilogram. So divided by 9.11 times the 10 power negative 31. The answer is 8.78 multiply 10 to the power 13. The unit is meter per second square. Now, next question. A simplified model of hydrogen atom, the electron is at a distance from a proton. Then this is the proton here. This is Q of proton. Okay. The proton charge, it is the same as electron charge, but positive, 1.6 times the 10 power negative 19 coulomb. And here, that electron at a distance of, so this is the distance, this is R, equals 5.3 times the 10 power negative 11. Calculate the electric field strength of the proton on this distance. So we need the electric field at the point A, which is Q over 4 pi epsilon naught R squared. This is from the formula sheet. By using substitution, Q is 1.6 times the 10 power negative 19 over 4 pi times 8.85 times the 10 power negative 12 multiply R squared in bracket 5.3 times the 10 power negative 11 all squared. By using the calculator, the answer is 5.12 times 10 to the power 11 Newton per kilogram. Now, next question. Van de Graaff generator has a spherical metal dome of diameter. So this is the Van de Graaff generator, and this is the diameter, 36 centimeter. We can get R. So R equals half 36. So it is here the diameter. Okay. So R equals 18 centimeter converted to meter, 0.18 meter. The electric field strength at the surface, so we have E at the surface, E equals 2 times the 10 power 4 volt per meter. Calculate the magnitude of a charge on Q. Which formula we did? E equals Q over 4 by epsilon naught R squared. Rearrange, so Q equals E multiply 4 by epsilon naught R squared. Substitute E equals 2 times the 10 power 4 multiply 4 by multiply 8.85 times the 10 power negative 12 multiply R 0.18 squared. By using a calculator, the answer is 7.21 multiply 10 to the power negative 8 coulomb. Remember, charge in coulomb. Now, next question. Two metal plates 15 millimeter apart. This is the distance. We convert to 2 meter. 15 times the 10 power negative 3. Have potential difference. We have V between them. The force on a smaller charge, this is F. Okay, calculate the strength of electric field. Which formula that join V and the electric field? E equals V over D. Then the electric field strength here, V is 750 divided by D in meter, 15 times the 10 power negative 3. The answer is 5 times the 10 to the power 4 volt per meter. The charge. We know that Q equals here from this formula. Okay, here E equals F over Q. Then Q equals F over E. F is the electric force. We have the force 1.2 times the 10 power negative, and the electric field we calculated 5 times the 10 power 4. So the answer of this one is 2.4 times the 10 power negative 12 coulomb. Next question. Two parallel metal plates are separated by distance, so this is D in meter, so 15 times the 10 power negative 3. The plates are in vacuum and the potential difference, so this is V, an alpha particle of mass, this is M, and the charge, this is Q. Initially at rest, initial velocity equals 0 and positive charged plate. Determine the force on the particles. F equals EQ. E is the electric field, V over D multiply Q. V is given 600, D is 15 times the 10 power negative 3. Q is the charge here on alpha particle, 3.2 times the 10 power negative 90. So the answer will be 1.28 multiply 10 to the power negative 14 Newton. Next question. The acceleration related to the force F equals ma. So the acceleration equals the force over m. M is the mass of alpha particle, which is given here. Here it is 6 point. This is the mass of alpha particle. Then we write F equals 1.28 times the 10 power negative 14 divided by 6.7 times 10 to the power negative 27. The answer is 1.91 multiply 10 to the power 12. The unit is meter per second. The speed of the particle. Oh, to get the speed, we know that the gain in kinetic energy equals the loss in potential energy. So we write the gain in kinetic energy equals the loss in potential energy, which is the work done. So half m v squared equals q times v. Okay, then half multiply m is the mass of alpha particle, 6.7 times 10 to the power negative 27 v squared. Q is the charge. Okay, here Q is the charge, which is 3.2 times 10 power negative 90 multiply V 600. From this we can get V squared and take a square root, so V equals 2.39 multiply 10 to the power 5 meter per second. This is the speed. Now Next question, but just we take a break, 2 minutes, and then return back. Yeah. Two-point charges A and B are situated distance 15. So the distance between A and B is 15 centimeter apart in vacuum. Point B lies on the line joining the charges. Distance x from charge A. The variation with distance is that one. This is the variation. So this is the electric field, positive and negative. So at this point, the electric field equal 0. When at x equals 10, the electric field is 0. Now, he said, by reference to the direction of the electric field, state and explain whether the charge is A, same or opposite. Of course, if they are positive and negative, the electric field has one direction, so not be 0. But if they are positive or negative, we can get a point at which E equals 0. Then they have the same charge because the field changes direction between A and B. Okay, then they have the same charge. Okay, now next. State why, although charge A is a pointed charge, the electric field strength between x and does not obey inverse square law. Because the field is not from one of charges. The field is resultant of the two fields, A and B. Now, next, we said use the figure to determine the ratio magnitude of a charge A to the magnitude of a charge. We know that the relation E equals Q over 4 pi epsilon naught r squared. Now, at x equals 4, here, at x, here, at x equals 10, so this is at x equals 10. At x equals 10 centimeter, the electric field is 0. Now, this is the total distance, it's 15 centimeter. Yeah, can return back here. It is 15 centimeter and x from A is 10. So this is at the point here. So this is the point B. X is 10 centimeter. So this is from A. So now the distance from B, 15 minus 10 is 5 centimeter. And the electric field at B equals 0. Then Q at A, because the electric field is 0, then they are equal. So Q at A over 4 pi epsilon naught. The distance from A is 10 centimeter, which is 0.1 meter. 0.1 squared equals Q at B over the distance from B to A, it is 5. So it's 4 pi epsilon naught 0.05 squared. Simplify, cancel 4 pi squared with this, and then you will get Q at A over Q at B will be 4 over 1. Next question. An electron starts from rest from the bottom plate in an uniform electric field. The potential difference across the plates is, so we have here V, and the separation we have D, 15 times the 10 power negative. Calculate the work done. The work done equals Q times V by on the electron. Q is the potential, Q is the charge of electron, which is given in the formula sheet, 10 power negative 19, and the V is given 1600. So the work done, it's 2.56 multiply 10 to the power negative 16 joule. The kinetic energy, gain in kinetic energy equals the work done. So gain in kinetic energy equals the work done equals 2.56 times the 10 power negative 16 joule. The speed, half mv squared, we use the formula to get the speed. So half mv squared, this is the gain in kinetic energy, equals the work done, which is 2.56 times the 10 power negative. On electron, so it is the mass of electron, so half multiply the mass of electron It's given 10 power negative 31 V squared equals 2.56 times the 10 power negative 16. From this, you can get V. V equals 2.37 multiply 10 power 7 meter per second. Remember, in speed must be less than the speed of light. The time taken to reach the top. Now here we have the distance. It starts at rest and move up 15 millimeter. Then, first of all, we calculate the acceleration. How? A equals F over M. Now, the force here we don't have. The force equals E times the Q. E is V over D times the Q. Then, this is the force equals 1600 over 15 times the 10 power negative multiply charge of electron 10 power negative 19. So the force equals here, okay, we can calculate the force from this formula. Then we can get A. So by substitution here for the force and the mass of electron here, the mass of electron 9.1 times the 10 power negative 31, we can get the acceleration. The acceleration will be 1.87 multiplied by 10 to the power 16 meter per second square. From acceleration, we can get the time taken. Which formula we use it? V equals U plus AT. Start at rest. So 2.37, this is the velocity we calculated before, 10 power 7 equals the initial is 0, multiply the acceleration 1.87 times the 10 power 16, multiply t. From this we can get t equals 1.27 multiply 10 power negative 9 seconds. Next question here. 2 pointed charges A and B separated by 12 centimeter. Charge at A is at point B lies on the line joining the charges. If the distance is from B to A is x, the variation with this is the voltage distance. Now you can see here the voltage up is positive and the voltage down is negative. So at V here, at x equals 4, the voltage at x equals 4 equals 0. Okay, now just this is the graph. He said used to determine the charge on the charge of P. Now V when x equals 4 equals 0. This V is the resultant voltage. So A, already we have the charge of A, but we don't have the charge of B. The charge of A, we use the formula here for V, remember? V equals Q over 4 pi epsilon naught R squared. Just use this formula for V. So the resultant voltage at x equals 4 is 0. So 2 multiply 10 power 9, this is Q1, over 4 pi epsilon naught R is the distance here. This is the distance, it's 4 centimeter from what? From A. 4 centimeter we convert to 2 meter. So it's 4 multiply 10 to the power negative 2. This is without squaring. I check the formula sheet here. Now, here, yes, without squaring. So this is V, okay, without square. So the formula sheet will help you. Don't worry. So here it's equals for now plus Q. The other one we don't have Q, but we have the distance. What is the distance? The total distance is 12. And the distance of B to A from the graph is 4. Then from B to Q to other B, 12 minus 4 is 8, of course, 8 centimeter. Then the other distance here, it's 4 by epsilon naught multiply 8 times the 10 power negative 2. The resultant at this point is 0. From this relation, you can get Q at B. So Q at B will be negative 4 times the 10 power negative 9 coulomb. Now, next question. The change in electric potential when B moves from position x equals 9 to the position x equals 3. Now we go to the graph. When x equals 9, here, when x equals 9, this is 9, it's in middle here. We find here at x equals 9, the potential difference is what? Is negative 10. And when x equals 3, now that is x equals 3 here at the middle between 4. So at x it will be here, this one is 2. 2 what? 2 times the 10 power 2, and this is negative 10 power 2 multiply. Then the delta V here, delta V equals 2 multiply 10 power 2 minus negative 10 multiply 10 to the power 2. The answer of this one will be 1200 volts. Now, state one similarity and one difference between gravitational potential due to a point mass and electric potential, phi and V. Phi is always negative, but V may be positive or negative. Then, the similar, it is proportional inversely to the distance. So, similarity, inverse proportional to distance, inverse proportional to distance, in both proportional inversely to R. But, okay, the difference, I said that gravitational potential is always negative, but the voltage may be positive or negative, depends on the charge. Now we go to the multiple choice here. Question number 34. We use the formula for this, V equals Q over 4 pi epsilon naught D. Then V dash, from this he said the charge is 2Q and the voltage is, the distance is 4D. Then it's 2Q over 4 pi epsilon naught and replace D by 4D. When you simplify it will be V over 2. Then the correct answer is V over 2. Now, next question. I said a point X is midway. Which of the following is the electric field strength at the point E? Of course, it's the direction from higher to lower. Positive 10, bigger than 0. So this is the direction of the field. Okay, downwards. The value of the electric field is V over D. V is 10 over D, 0.2 because it's centimeter. Then the answer is 50 volt per meter downwards. Then the correct answer is B. Next question. Now, in that one, what is the charge on the oil here? Of course, we have two forces because the oil here has mass M. So the weight acted downwards, mg, and the electrostatic force is F. They are equal. So F equals mg. F equals EQ equals mg. And E is V over D multiply Q mg. When you rearrange this formula, you will get Q. Then Q equals mgd over V. Then the correct answer of this part is C. So this is the question. I return back to read it. What is the charge on the oil? Now, question number 37. This is the electric field. Because the electron is negative, so the force is opposite to the electric field. So the answer is D. Now, next question. Which diagram best represents a field line? Of course, we know that the field lines comes from positive to negative, so the correct answer is B. Last question here, question number 39. Remember, the electric field strength is the same at all the points inside the field, but the voltage near to the positive is higher than the voltage near to the negative. Then the correct answer is D. Okay, and now we revised most of important questions about the syllabus. I hope you understand this lesson. Thank you.